So you could even do that with a step. If students have this as an assignment, a page like this or any kind of graphic, you could simply have them work like this kind of across it and figure out that first, because it's often a place where students struggle. As you can see in the completed worksheet here, it's also a good idea for students to list then, once they've found these little pieces, and they can even color them in chunks like that, to label the dimensions of the sides there and to circle the volume on the inside. And by doing their work really cleanly like this, it helps them to be able to add it up and find the answer. Sometimes I find that students who are getting this wrong are getting it wrong because they're trying to do all this work in their head. Not that a fifth grader can't do it in their head, but by doing it in their head, it gets a lot. There's a lot greater chance they're going to forget some number or misadd something, and they need to show neat work like this. All right. More graphics to look out for. This page right here is the second part of it, and this is just the front page, if you will. It's just these things, but they're shown a little bit differently. The challenge here for students is that when you look at these two things here, you need to try to split them into volumes like this. Now you can split them all sorts of ways. As you see here, I just split this one into a vertical one and a horizontal one next to each other. I put the dots on the corners. One of the troubles students have is that if I go back a page and show you this graphic, it might be the student thinks of it this way, and they cut this across like this, and they say that they see this square and it just kind of jumps out to them. That makes more sense like this. And they certainly can do it that way, because these two volumes, when you find each of these smaller pieces, they'll add up to make the same volume. Both of these graphics should add up to 624, even though the work might be different. So again, if I've done that, because I see that, then I'm going to look for a point and look for 3 dimensions off of it. So I can see my back is 6, so the front here is 6. Whoops, don't want to put my hand in front of the camera. It's 9, and 4 is on this side, so that has to be 4. So I've got all the pieces on this side. The volume of this is going to be 6 times 9 times 4. It doesn't matter what order you put those in, because the commutative property of multiplication says the answer is going to come out to the same. The volume of this one on the bottom, well, it's 6 tall and it's 17 long. So there's 2 sides. Oops, I kind of messed that up. I should have gone like this and left that side not red. So it's 17 by 6. And then if you were to imagine, I try to teach the students, imagine this. If I have this little brick and this sort of looks like the same thing, you know that this length and the length inside there and the length on this end and the length on this bottom are all the same. It's not a bad idea if you have Legos at home to make some sort of little thing like this, just to have the students holding it next to it so they can really think about how those dimensions transfer from one edge to another. So if this is your unknown edge down here, you know it has to be 4 because it was 4 up there. And so the volume of this one would be 17 by 4 by 6. And again, you would need to neatly calculate your work, perhaps like I've done here, and then add those up to make that volume. The last part of this worksheet is asking students, a different graphic, I guess I should say, because they may not have this worksheet. Ask students to look at the base and try to figure out, well, if that's the base, what would be the dimensions of that base that I would multiply 5 to get the volume of this? And the thing students need to realize is that all that we're looking for is the factors of 28. Anything that multiplies to make 28. Usually the first one would be like 4 times 7 that students might think of, or 30 they might think 5 by 6. Now again, you could say, well, 1 times 28 are factors of 28, but does this box really look like it's 1 by 28 on the bottom? Wouldn't it be really long and skinny for 1 by 28? So we really don't want to see students do 1 by 28. We want to see them use dimensions here that might be realistic for this. So if this up here looks like 5 by 6, maybe it looks like 3 by 10, but probably not. It looks almost squarish on that base. So coloring the bases like this might be one way to help a student see how they are to do the multiplication there. And these are 4 different graphics that students ought to be able to use to find volume of rectangular prisms.